Part of what I was asked to do as a preliminary for this lecture I'm giving at the International Space Elevators Consortium's conference in September is to come up with the physics and engineering justifications for the project, which I believe would be considerable. I believe that the amount we stand to learn about engineering technology as an outcome of this concept, this experimental notion of a very large tower extending all the way to low Earth orbit, which would suspend an elevator cable and allow a craft to go up and down it, both allowing us to get objects into space and to return objects from space. It opens up a large vista of opportunities, and there is one central idea that I've been working on for several years, which connects to fusion propulsion and fusion energy in space, which I believe could be one of the most transformative technologies that we've ever developed and may ultimately allow us to have total control over matter in the future. So when it comes to fusion technology, we have made great strides towards the viability of commercial fusion technology in recent years. However, we still face great limitations in the viability of fusion technology, like very simply really because what we're doing on Earth with fusion is building these huge tokamak devices and other forms of fusion reactor that house the reaction, that seek to contain these plasmas, which are of course heated to temperatures many times that of the surface of the sun, and are contained with extraordinarily strong magnetic fields. We have a few years ago, I believe a couple of years ago, recently gotten more energy out of the reactions than we put into them. So we've been continually learning more about fusion all the time, and it's increasingly seeming likely that nuclear fusion will be viable. However, in terms of its true viability, we don't know quite whether or not the energy that we're getting out of those reactions is merely greater than the amount of electricity that's going into powering these very strong electromagnets that generate the magnetic field, or if it's actually greater than the total amount of energy put into building the reactor in the first place, and if the energy we're getting out of it, is going to be sustainable over the long term without having to, in essence, every few years or so, or even every few months, for all we know, build an entirely new fusion reactor. So what I've been speculating about is this notion that Earth might not actually be the best place to be undertaking nuclear fusion, and that the containment of nuclear fusion reactions might not actually be the most sustainable, viable, or desirable outcome for the adaptation of nuclear fusion technology to energy production, or really for any other purpose. So, what I designed, or what I put into the preliminary stages of the design process, was a different form of fusion device, utilising very strong magnetic field generators again, but loosely housed in space, and reducing the number of components to a minimum, and allowing us to create something like an artificial star in space that is contained by a magnetic field again, but these are sort of like floating curved shaped magnetic field generators, and the reaction in the middle, and these like arc-shaped reactors, magnetic field generators rather, was be able to move inwards and outwards, thereby protecting them from the extreme temperatures encountered in the fusion reaction in the center of the device. So we could, for instance, put these objects in orbit around Mars and use them potentially in the future to generate a lot more light, i.e. heat, because light is sort of the same thing as heat, really. Visible light produces heat as well as infrared and the rest of the electromagnetic spectrum. Cooks things, right? So light is heat, basically. So we could be using them to, yes, generate a lot more heat for the surface of Mars and visible light that plants could potentially photosynthesize with. melt all the ice on Mars and have liquid water on its surface again, and really begin the process of terraforming Mars. So that's one interesting possibility. The other interesting possibility is a real game changer, and it's seeming to me to be viable within the next couple of decades, but probably if and only if we build a space elevator. The other possibility is that we could be using the same technology to fuse lighter elements into heavier ones. Lighter, more abundant elements could be fused by the R and S processes, these processes that go on in supernovae, and we could imitate those magnetic field generators in space and in essence print, for instance, as much gold as we'd ever need or want out of lighter, more abundant elements in the periodic table. So this could give us total control over matter. It could also have utility in propulsion. I've designed the preliminaries of a propulsion device which I suspect might be able to achieve light speed velocities one day, utilising a combustion chamber containing a fusion reaction, then firing it out the back end of an engine with rotating magnetic fields at the speed of light, and via Newton's third law, I think we could end up with something like a craft being propelled forward at speed getting close to light speed, maybe. Again, like, this requires not just the work of a single person, but the work of an entire team of engineers working on the problem. So yes, a space elevator, the physics justification for it is we could do a lot more interesting physics in space if we could simply get more material into space more regularly. So it could be a great boon for the subject of experimental physics, I think. We could be building particle accelerators in space. We could be getting muon G-2 experiments in space to see how closely the G factor of the muon, for example, accords with the predictions of the standard model in microgravity, which is, I believe, the next step in the way of figuring out to what extent the muon G-2 experiment tells us something about quantum gravity, which I suspect it is a deeply insightful experiment in that sphere of theoretical physics. I believe it tells us quite a lot about what's going on at the quantum level, so far as gravity is concerned. And the engineering justifications, well, if we can build a structure that's large and tall, then we change the game in engineering, have we not? We've radically altered aeronautical engineering, aerospace engineering, space engineering, indeed civil engineering. And then there's other things like the applications of soft robotics into the project to construct various stages of the elevator and to also maintain it. I'm a big fan of trying to integrate things like that into the system. I'm getting messages on my phone at the moment saying low memory, so I might just cut this video off here because I think I've said some important things in this video and some things that everyone should really consider. And this is just yet more practice for this lecture in September. So thank you for watching. Bye, love you lots.